Cool. Technical failure aside. How do I turn those lights on? Awesome. Okay. So some technical issues aside, this is programming. I'm Sam. I spoke to you all this morning about competition in general, and I actually want to start not by talking about programming, but by asking you guys a bunch of questions. So, put your hands up if you've never been to the competition before. Again, that's like, I'm amazed at how many people keep them up. So now, I want you to keep your hand up if you've ever written a program before, some software, Python, anything like that. Excel doesn't count, but apart from that, hands up. Wow. Okay, so like most of you have written code before. That's cool. All right. Maybe I don't need to say anything then, but just in case you don't know how to write code, I just want to say, it's awesome! It's like the best thing that I do all day, every day. So I'm studying computer science, and basically I wouldn't be if I didn't think that writing code was just about the most fun thing ever, because you go from sort of nothing to this cool system that can manipulate stuff really quickly. And in Rob's electronics talk, he sort of showed you our docs. I think you should read them some more. They're kind of important, and I actually have a story to illustrate this now that I didn't have last year when I did this talk, which so we just sort of started up again at Bristol with the new term, and we recruited a whole bunch of new freshers. And I was showing them our robot, and I wrote like a quick program to go in it, just thinking, it'll be fine. I didn't actually look at the docs at all. And we put it on the USB stick and plugged it in, and it blew up. Just like, didn't work. Program crashed, first line of code. I was like, oh yeah, that's not how you do that. And had I read the docs at all, this would have been obvious. In fact, I should have just copied straight out of our first example, because it's the exact same behavior I was going for. So, yeah, read the docs. No, really, the docs are important, and you'll learn lots of things by reading them. If you're not sure how to get at them, they're there. And I figured that you needed a wall of fire to remind you how to get to the docs. So with that, let's talk about programming. This is not how you do programming. If you're slapping your keyboard, something's gone desperately wrong. So what a program is, a piece of software, is it's essentially a sequence of instructions. And your computer just goes through these really, really quickly. Earlier, Rob gave you a clock speed in the hundreds of megahertz range. What that sort of means is that your CPU can do hundreds of millions of instructions every second. And that's really cool, because that kind of gives rise to the software. And you basically just list the instructions you want the robot to do, like go forward, turn left, and some stuff happens. Software on its own is great, but you need to actually be able to understand things in the real world. And Rob talked about this in terms of a robot with motors that doesn't sense things isn't really a robot at all. And so you can wait for events, like wait until a camera has processed a frame and then do something with that frame. You can wait for switches to be triggered. And you can also actually pull those values as well without having to wait for a change. And there's this idea of control flow, which basically says, if some condition, do something, otherwise do something else. And this allows you to kind of change your behavior based on what's happening in the kind of world around you. And a good example of this is, if you can see a marker that's to the left of the vision image, you're probably going to want to sort of turn in that direction. If you can see a marker that's to the right, you're going to want to turn that way. And this is a case where you would actually use a sort of if to do that. Our robots are programmed in Python, which we picked basically because it's a easy to learn, very easy to write programming language, and also the code can look a lot like English, and if you read it ignoring some special bits, it does actually kind of make sense in your brain, which is great. There's this guy who basically says, if you've got a bug in your software, it's not because you're not a good programmer, it's because the problem you've described is too complex, and we try to break that down by using a simple programming language. I'm now actually going to show you some code. Don't panic. If you don't understand what's going on, that's fine. I say that I believe that programming is kind of hard to teach and easy to learn. It's one of those things where you can sort of give people examples all day long, but if they're not actually doing any, it doesn't work. So with that, let's actually dive into some code. So this is just about the simplest program you can put on your robot. And what this will do is, the first line is from SR import star. That basically pulls in all the stuff we've written to make it easy to interface with the electronics in your robot. And then it will put the words hello world on the robot screen. It'll also write them to a little file on the USB stick. And then it'll stop. The robot won't do anything. I would very much encourage you guys to type out this into our IDE, which I'll show you later, and actually see what happens when it goes into the robot. Now I'm going to show you a slightly more complicated example, which this is some code that will cause your robot to move. So again, from SR import star pulls in all the stuff to do with the robot. Import time pulls in things to do with time. In this case, we're going to use it to make the robot stop doing something for a certain amount of time. R equals robot basically creates a robot name thing that contains all the stuff specific to your robots. Don't worry too much about the details of that right now. And then we say to R motor 0, target is 100, set the target power of motor 0 to 100. This is power, not speed. It's worth noting that power is completely not linearly related to the speed that your robot moves at all. Just if you do this, your robot won't go straight. I don't care how perfect an engineer you are, your robot will not go straight. So this sets the two motors to go forward at full force, and then waits for 10 seconds, and then it stops. So now I'm going to show you the IDE. I'm going to talk, and Rob's going to drive, and it's going to go pretty well. I'm also going to show you a little bit of Python stuff. So if we tab out,
we need to drag that onto the other screen.
Can you log in?
Let's see.
Well, I can drag it around for a bit. Hang on.
Yep. Sorry, I can't use that. Mouse. Right.
So this is the IDE webpage. It's hosted on our website, studentrobotics.org/IDE. When you hit this, it'll ask you to log in with a username and password, and that's kind of how we identify who is who. For all intents and purposes, we'll give you usernames and passwords within a few weeks. Your teachers have to kind of register you. When you log into the IDE, you need to create a project, which is basically where you store all the code for your robot. So you click on New Project, give it a meaningful name. We like meaningful names. Rob, you're a smart person. I'm sure you can figure something out. Yeah, that's super meaningful. And so you click Save, and basically it will create this project for you with one file in it called robot.py. Which by default will contain no code. This is the file your robot first searches for when you power it up, and you have to have one, and it has to have some code in it in order for your robot to do anything. So if we click on that, it should take us into the code editor, which will be blank. And this is where you can write some code. Rob? Rob's going to write a program.
Oh, okay, we'll try to do this.
Yeah. Okay. Rob did a while loop. So what this while thing does is it basically says, while the condition next to me is true, keep doing this block of code. And in this case, true is always true. And so it's just going to print Nyan onto the screen forever until you power the robot off or it runs out of battery. So once you've kind of edited your code and you're happy with it and you click on the Save button, it'll ask you for a commit message. My advice on commit messages is you should describe what you've done and why you've done it. And there's basically... No, I think there's one N. No? Anyway. So this is what he's done and why he's done it. One beautiful. So yeah, the reason for this is basically so that if you go away and you've been writing some code and your team members come to look at what's actually happened, they need to understand what changes you made, just opposed to go, oh, there's some code, what do I do with it? So once you've done that, if you click on Save, so yeah, forever, yeah. Ignore that, we fixed that. I think.
Every year.
Every year. So basically, after the file has been saved, it gets saved at that version with that name, and we store these sort of commit messages forever. And you can go back to any particular one that you want to, check out the code, copy parts of it into your new code, whatever. And so we're basically keeping a full history as you make changes. And we think this feature is really useful because it means that you can kind of revert if you break something and it'll still work. And this is really important. So once we've done that, if we go back to the Projects tab, you'll see this button which says Export Project. And what this does is you click on it, and it manufactures a zip and asks you to save it. And then you point it at a directory and press save. Just press save. And then it downloads. Here, it's put robot brackets 1.zip. And that's actually really important, because many browsers will do this. If you're downloading a whole bunch of robot.zips continuously, your browser will kind of increment the file name. It has to be called robot.zip in order for it to work with the robot. And you can delve into the contents of this zip file if you want to. It's basically a bunch of R code with a bunch of your code inside it. And yeah, so you put that zip file on your USB stick, you safely eject it, because otherwise it won't work. Then you plug it into the robot, and it should be good to go. What are you doing? That won't open.
Don't worry.
It does weird. Yeah, cool. That's the idea. Cool. They sure it's big. Now, I'm going to show you some simple Python code, which may or may not work. So here I'm actually using what's called a Python shell, which is basically a sort of interactive prompt you can type code into and see what the results are. This is available for like Linux, Mac, Windows. If you're running Linux or Mac, it's built in. If you run Windows, you can download it off the internet. It's free, and this is kind of good to play with for kind of example purposes. So here I've run just the line print programming is awesome, and we've got the result programming is awesome. The other thing that's probably worth showing is like some simple variables. So a variable is a name for a value. So here I've taken the expression 3 plus 1, evaluated it, value is 4, and stored it in the name variable. And this basically means that I can reference that further down in my program. So I can also do like it's 5, right? And so learning to work with variables is a good way to make your program more readable and probably necessary and good. There are also things called functions and objects, which you may want to look into as your program becomes more complicated, but I'm just kind of going to skip over those for now. So, back to the presentation. Bugs. Bugs are bad. Bugs make everyone sad. Bugs are when your robot does more or less the exact opposite of what you wanted. And I guess, basically, these are where your robot will do exactly what you tell it to in the code, which may or may not be what you actually want to happen. And sometimes it's hard to read software and understand what's actually going on. So I'm going to try and give you some advice on how to kind of take a buggy program and make it less buggy. So the first one, read the docs. This is really, really important. Basically, if you've got a bug and it's because maybe your robot's turning the wrong way or it's not responding to the right I/O, you might want to look at whether you've made a mistake when you're interfacing between your code and our code. Oftentimes, you'll see an error on the robot, and these are actually really helpful. These often tell you exactly what line your program went wrong on, and they can be things like syntax errors, which means you kind of wrote the program wrong and there's a problem there, or something more complicated where maybe you've tried to add a word and a number together, which doesn't really make any sense. If you're still stuck, Google. In all seriousness, this is a really powerful resource to be able to find like where there are problems. So if you've got a problem, it's likely it's come up before for someone else. It's likely that they've already found a solution. And that's really good, because that's kind of teaching you guys how to research your way to solve these problems. And if you're still stuck, if there's like no solution, you've got no idea what's going on, ask us. There are some people in Student Robotics who have freakishly good programming talents. we have our forums, which is our sort of advised method for getting help, because we're on there nearly all the time, because half of us have weird sleep cycles. Your mentor may also know the answers, and if not, they'll know where to go for help. And these issues can actually range from not just in software, but also any electronics or mechanical issues you're having. And not only can we answer these, but like everyone in here can answer the questions on the forums as well. And often, if you guys are helping each other, that's great for us, because A, it means the problems get solved before we catch them, and B, it means that you guys are learning things, which is great. If you are going to post on the forums, though, please flood us with like information about what's wrong. Send us pictures, like show us your code, show us what the robot screen is doing, tell us what it's doing. If it's not moving, tell us, like, is your battery charged? All of this information is really, really important. This, feature creep. So some of you may be tempted to just like start coding straight away and build a really, really amazing, awesome program. My question to you is, does a razor blade need jetpacks?
Yes.
If the answer to that question is no, then you've probably put too much in your software that isn't actually helping. You should start with a very simple program and grow it towards what you're actually trying to do, as opposed to trying to code everything and like it breaking and you having like 100 lines and you've got no idea where the problem is. And this is called kind of, you start small and you debug towards a kind of solution. Software, you should test it. So some people have said that the robots behave differently between development mode and competition mode, and they will. And we've got some stuff in place for you to put your robots in competition mode whilst you're building them. And you should test it in both, because if there's a problem that emerges, you don't want it to emerge in competition mode at the competition. You want to have tested it beforehand to make sure that it's actually working. And with that, I will take any questions anyone has. Yes, Rob?
How do I test a robot?
You put your code in it, turn it on, and press the go button.
But what about where would I test a robot?
Oh, right. So yes. To be honest, if you're testing a robot, anywhere is fine as long as you've got some well-lit markers and you kind of, the simulation that you're performing is a realistic one of the arena, right? We kind of tell you how we're going to light the arena, what the tokens look like. We give you sample tokens to print out and test. These things are important. We're going to run tech days where we're hopefully going to have kind of simulation arenas that you guys can drop your robots in and see what happens. But yeah, I mean, it depends on your workspace, your robot, how much space you need, what resources you have, that kind of thing. But yeah, you should test in simulations of the arena. Yes?
Do we have to use your IDE?
You do not have to use IDE. We have a bunch of scripts that allow you to construct a zip file that looks like the one the IDE serves. Those are open source and you can read the code. We recommend that you use the IDE because that's how we test that, right? And we build that and we kind of try to make sure that that works. But you absolutely can just write your own Python scripts if you feel like it. That's totally valid. And in fact, I think some people within Student Robotics do that instead of use the IDE, so yeah.
So we can customize your libraries and stacks and things.
Okay, I would definitely advise against that because the library that we write has been designed, it's kind of got multiple levels, right? At the lowest level, it talks directly out to the other boards, and at the highest level, it presents a nice interface for you guys to control motors and servos and stuff from. I would definitely tell you not to mess with that low-level stuff because that's kind of fragile and has been tested very heavily by people who have lots and lots of experience in this area. But I mean, there's no reason that you couldn't build your own layer above that to do other things. It's just at that point we stop being able to give you support, right? We only really want to support this layer that the very furthest out layer that we've built because that's kind of how we program our robots too. That's how everyone else is doing it. And if issues arise there, they may have to be changed in a deeper level that then breaks your stuff that you're kind of doing that's not official, if that makes sense. I mean, we only support the very furthermost out layer, but you can do whatever you want. I would just advise against it. Yes?
Point out that if there are bugs, we will fix them.
Yes.
Yeah, could you point that?
Yeah, so if there are bugs in the Python sort of stuff we give you, they will get fixed. They will get fixed relatively quickly as well, because we don't want you guys to kind of be suffering under the fact that the robots work at doing something. And again, if you go off on your own, that could end badly for you. Any more questions? Andy?
I don't know anything about Python. I'm going to go to get started.
Google? No. So, I mean, our website, in the documentation, we have a link to a number of Python tutorials. We actually have our own Python tutorial for, like, specifically for programming the robots. These are all good resources. If unsure after reading stuff, ask on the forums, and we'll try and point you in the right direction. For those of you that see mentors, those guys will be encouraging you often to look at code, and early as well, because it is difficult. And people always underestimate how long it takes to code. And I said this earlier, I'll say this again. Everyone in your team should be writing code, because as Steve is going to tell you about, the coders always disappear. In fact, at Kickstart last year, one team said, I can't remember what question, but it was, oh yeah, our coder's not here. And we just all went, so yeah, you should be writing code. Yes?
I don't know the Python for VB, which we've been doing, so.
You've been doing VB?
Yeah.
So,
good luck.
I don't want to.
So, I mean, like, I'm going to answer from some kind of personal perspective here, which is that VB is a world of pain, and that I spend lots of my spare time coding Python. The concepts are the same, right? So, fundamentally, all programming languages at some level deal with processing data and instructions together to come up with a result. So, I mean, you should be able to pick up Python like more quickly than from scratch with VB, because you're already used to programming. But like, yes, Python is like a whole world nicer to code than VB. I don't know anyone who like willingly codes VB in like the real world. Whereas I think everyone in the room who's a blue shirt has coded Python for funsies at some point. Cool. More questions, or are we done? Oh, there's one on right at the back.
Well, it's just worth pointing out that at the top of the Python tutorial, there are some links to Python shells that you can use in the web browser.
Yeah.
So you don't have to install it on this knockdown school machine or anything like that.
So yeah, for those of you who couldn't hear that, the reason our ID is in the web is that your school hopefully won't block it. We had one last year that did, which was like, what? Similarly, there are Python shells on the web that you can run in a browser that even work in Internet Explorer, that you can sort of test code in the same way that I was running it on my Mac. And that's kind of a very good way if you just want to quickly work out how something's going to run, and you don't want to have to like make a USB key, plug it into your robot, power the robot up, and see what happens. Yes?
Will the SR thing work on the web shells?
No, because SR is something we've written that is actually only made available when you create it. So yeah, don't like try from SR importing stuff anywhere other than in our IDE, or it just won't work. Jeff?
Yeah, I just wanted to point out that like, Python is in real stuff. Like, you know, like Google made a Python and all this. So yeah, sort of a bit different from VB. It's everywhere.
Any more questions from someone who isn't a blue shirt? Cool. Okay. I think I'm done. And Alistair is next.
Just